Welcome to our lesson on mastering Pandas for data analysis. Introduction to Pandas and its role in data analysis. Pandas is one of the most popular Python libraries for data analysis, data cleaning, and transformation. In this lesson, you will learn how to explore, prepare, and analyze real-world data using Pandas. We will use the Titanic dataset to practice key skills such as filtering, aggregating, and visualizing data. Running the cell now. Let us get started. Think about a question you want to answer using the Titanic data. Let us set up our workspace by importing necessary libraries and loading the Titanic data. The warnings module keeps the notebook quiet by hiding warning messages. We set warnings to be ignored so they don't clutter the output. This comment indicates we are importing the Pandas library. Pandas is a powerful tool for handling tabular data. Here we import it as PD. Import numpy as NP. We set the random seed to 42 for reproducibility. This comment explains that we will load the Titanic dataset from a GitHub URL. We define the URL string where the Titanic dataset is located online. We use Pandas to read the CSV file directly from the URL into a data frame named df. This comment notes that we will print the shape of the dataset, rows, columns. We print the shape to see how many rows and columns the dataset has. This comment indicates we want to show the first 3 rows as a preview. We print the first 3 rows to quickly inspect the initial data loaded. Running the cell now. This output confirms that the Titanic dataset contains 891 rows and 12 columns, giving us a moderate-sized tabular dataset to work with. The preview of the first 3 rows shows key columns like survived, P-class, sex, and age, which will be important for our analysis. This initial exploration helps us understand the data structure and the types of information available for filtering and aggregation in future steps. Try finding information about one column in the preview above. Let us learn what a data frame means in Pandas. What is a data frame? A data frame is a 2-dimensional table used for storing data. It is similar to a spreadsheet in Excel or a SQL table. Each row is an observation, and each column is a field or variable. Pandas makes it easy to manipulate, filter, and analyze these tables. Running the cell now. Think about where you have seen data tables before. That is what a data frame looks like. Let us explore the features of our Titanic data frame. This prints the data type for each column, such as integer or string. This shows the data types of all columns in the data frame. This gives us a full summary. It shows how many non-missing values each column contains, and their types. Running the cell now. This output shows the data types and completeness of each column in the data frame, revealing it has 891 rows and 12 columns with mixed types like integers, floats, and objects, strings. Notice some columns like age and a cabin have missing values, which is important for understanding data quality before analysis. This step helps you get familiar with the structure and content of a data frame, key to efficiently manipulating and analyzing tabular data in Pandas. Challenge: which columns in this dataset might have missing values? Let us quickly explore basic statistics of the Titanic data. This describes numeric columns in the dataset, giving statistics like mean, minimum, and maximum. It helps us get a quick sense of the data values. Running the cell now. This output shows summary statistics for each numeric column in the data frame, such as count, mean, and standard deviation. Notice how the count varies for age because of missing values, highlighting the importance of data completeness. These statistics give a quick overview of the dataset structure and help identify key features before deeper analysis. Try running .describe on other datasets later to compare their ranges. Everyone deals with missing values at some point in data analysis. Data cleaning, handling missing values. Real-world data is rarely perfect. We often have to deal with missing or incomplete data. In Pandas, we can easily check for missing values and decide how to fill or drop them. Running the cell now. Have you ever worked with incomplete survey results? That is similar to missing data in a data frame. Let us count how many missing values are in each column. This line counts how many missing values are in each column of the data frame. This line prints the count of missing values per column to the console. Running the cell now. This output shows the count of missing values in each column of the dataset, revealing that age, cabin, and the embarked have the most gaps, with cabin missing 687 entries. Noticing which columns have missing data helps us decide where to apply filling or removal strategies, crucial for preparing the dataset for analysis without losing too much information. Which fields would you want to clean first if you were the analyst? Let us remove rows where the age is missing. Dropping rows with missing age helps create a dataset where every person has a known age. We make a new data frame called df_clean with only those rows. We print the shape to see how many rows remain after removal. Running the cell now. The output shows that after dropping all rows with missing values in the age column, the dataset now has 714 rows and 12 columns. This indicates how many entries were removed due to missing age data, highlighting the impact of handling missing values on the dataset size. This step is crucial for ensuring clean data for analysis without losing too much information. Try dropping other columns or using a different threshold for missing data. Let us practice filling missing values instead of dropping them. We find the most common value in the embarked column. This is called the mode, and we use it to fill missing entries. We fill missing embarked values, keeping as much data as possible. Check to make sure all missing values for embarked are gone. Running the cell now. Here, the code fills missing values in the embarked column with the most frequent value in mode. The output shows 0 missing entries remain, confirming that all nulls were successfully replaced. This step ensures the dataset is clean and ready for analysis without losing rows to missing data. What kinds of columns make sense to fill instead of drop? Now let us learn how to narrow down the data for focused questions. Selecting and filtering data. Pandas makes it easy to filter rows and select specific columns. You can use Boolean expressions, comparisons, to get just the data you want. Running the cell now. Where would filtering help you answer business or research questions quickly? Let us get only the female passengers from the Titanic data. This filters the dataset to show only rows where the sex is female. We store the result in a new data frame called females. We preview the first 3 female passengers. Running the cell now. This output shows the first 3 rows of the filtered data frame containing only female passengers, as selected by the Boolean condition df sex == female. Notice the shape remains the same except only females are kept, allowing us to focus analysis specifically on this subgroup. This demonstrates how filtering helps isolate relevant data based on a condition. Try changing female as male and see how the preview changes. Let us find all children on board. This looks up all rows with age less than 18. We make a new data frame called kids to store only these passengers. We select and preview just the name, age, and sex columns for these passengers. Running the cell now. Here, we've filtered the dataset to show only passengers younger than 18, selecting key columns to inspect their details. Notice how the output lists names, ages, and sexes of just the kids, demonstrating how Boolean filtering helps isolate specific groups within data. This highlights how Pandas makes it easy to focus on relevant subsets by combining conditions and column selection. Can you find the youngest passenger? Try using .minute on the age column. Sometimes we do not need all the columns. This step makes a simpler data frame with just the name, age, and fair columns. It is useful to focus only on the variables you care about in your analysis. We print the preview for a quick sanity check. Running the cell now. This output shows the first 3 rows of a new data frame containing only the selected columns as name, age, and TFAIR. Notice how the data frame shape has been reduced to just these key pieces of information, demonstrating how column selection simplifies your data view. This is an important step for focusing analysis on relevant data and preparing for further filtering. Which 3 columns would you pick if you wanted to know who paid the most? Let us look at grouping rows by category and summarizing results. Grouping and aggregating data. Pandas lets you group data and calculate summary statistics easily. This is powerful for answering comparison questions, such as survival rate by gender. Running the cell now. Grouping is one of the fastest ways to spot patterns in your data. Let us find out how the ticket price varies by passenger class. Calculate the average fare for each passenger class. Group the data frame by EP class and compute the mean of the TFAIR column for each group. Output the average fare for each passenger class. Running the cell now. Here, the code groups the data by passenger class and calculates the average fare for each class. Notice how the average fare drops significantly from first to third class, highlighting the price differences among classes. This demonstrates how grouping and aggregating can reveal key trends in data for comparison purposes. Which class paid the most? Can you guess why? Now let us compare survival rates for men and women. This comment indicates that the following code calculates survival rates by gender. This groups the data frame by the sex column and computes the average of the survived column for each group. This prints the survival rates for each gender group. Running the cell now. This output shows the average survival rate for each gender, calculated by grouping the data by sex and then taking the mean of the survived column. Notice that females have a much higher survival rate at about 74%, compared to males, about 19%, which highlights a key insight into the dataset. This demonstrates how grouping and aggregating can quickly reveal important patterns in categorical data. Why do you think the survival rate differed? Let us group the data by both class and gender. This line is a comment explaining the next operation. We group the data by passenger class and gender, then sum the survived values to count survivors in each group. We print the resulting counts to see how many survived in each class and gender combination. Running the cell now. This output shows the total number of survivors grouped by passenger class and gender, highlighting how many females and males survived in each class. Notice the clear trend that females consistently have higher survival counts than males across all classes, and first-class passengers generally survived more than those in lower classes. This demonstrates how grouping by multiple columns helps us uncover detailed comparisons within the data. Practice: group by embarked and plot counts for survival. Let us learn how to combine data from more than one source. Merging and joining data frames. Sometimes you need to combine information from multiple tables. Pandas makes it easy to join data, similar to SQL joins in databases. Running the cell now. Have you ever created a spreadsheet using information from different people? That is similar to joining tables in Pandas. Let us join our Titanic data with a new table of loyalty points. Simulate joining by adding a new column with random loyalty points. Import the NumPy library to work with random numbers. Set a fixed random seed to ensure reproducible results. Create an array of random integers representing loyalty points for each row in DF. Create a new data frame with passenger ID and their corresponding loyalty points. Merge the original data frame with the new loyalty points data frame on passenger ID. Print the first 3 rows showing each passenger's name and their assigned points. Running the cell now. This output shows the first 3 rows of a merged data frame where the original passenger data is combined with randomly generated loyalty points using a common key, passenger ID. Notice how the points column aligns correctly with each passenger's name, illustrating how merging joins tables on a shared column to enrich the data. This confirms the key concept of combining datasets to create more informative tables. Try adding another column to DF2 and joining again for practice. Do not forget to subscribe for more Pandas tutorials. Now let us look at how to make pivot tables for powerful summaries. # pivot tables and data reshaping. Pivot tables let you reorganize your data for easy comparison and quick summaries. Pandas can turn long tables into wide tables for reporting. Running the cell now. Think about what rows and columns you would want to compare side by side. Let us make a quick pivot table to compare groups. We are creating a pivot table to analyze survival rates by both the port where passengers embarked and their passenger class. This line generates the pivot table using the mean survival rate, indexed by embarkation port and with columns as passenger class. Finally, we print the pivot table to see the summarized survival rates based on these categories. Running the cell now. This pivot table reshapes the original data to show the average survival rate by port of embarkation, rows, and passenger class, columns. Notice how survival rates tend to be higher for first-class passengers, P Class 1, across all ports, highlighting class-based survival differences. This transformation makes it easier to compare patterns and trends in survival across multiple categories at once. Try changing AggFunc to sum or looking at other combinations. Let us visualize patterns in the data. # time series example, plotting age distribution by class. While the Titanic dataset is not a time series, we can explore trends within the data, such as age distribution. Pandas integrates well with plotting libraries for visual analysis. Running the cell now. Why is seeing a pattern on a chart sometimes easier to understand? Let us plot a box plot to visualize how passenger ages vary by class. Matplotlib lets us plot charts directly from our data frame. Here we create a box plot, which summarizes the spread of ages in each class. We set a clear title above the plot. We leave out the default Matplotlib subtitle for a cleaner look. This labels the x-axis by class. This labels the y-axis by age. This line draws and displays the plot below the code. Running the cell now. This box plot shows the age distribution across the 3 passenger classes on the Titanic. Notice how the median age and spread vary by class, with first class generally having older passengers compared to second and third classes. This visualization helps us understand demographic differences within the dataset and highlights how Pandas and Matplotlib can be combined to analyze group data. Try plotting fare by sex or age by survived for more practice. Time for a real-world practice using Pandas. # mini project, simple Titanic data exploration. Let us put everything together with a short exercise. Can you find all female passengers in first class, calculate their average age, and plot fare versus age? Running the cell now. Pause here and see if you can solve it before watching the solution. Let us answer our mini project step by step. Here we filter the data to keep only females in first class. We save the filtered data as first_female for reuse. We preview the name, age, and fare of the first few rows to check our filter. We now calculate the average age of these passengers. We print this average in a friendly format. To explore further, we plot a scatter chart of fare versus age. Label the horizontal axis as age. Label the vertical axis as fare. Add a title so anyone knows what the plot shows. Show the plot for easy visual inspection. Running the cell now. This output shows the first few first-class female passengers with their ages and fares, confirming that the filtering worked correctly. The calculated average age of about 34.6 aligns with the selected group, giving a sense of the typical passenger's age. The scatter plot visually compares fare prices to ages, helping us see any patterns or trends in ticket prices among these women. What other slices of the data could you explore using similar code? Now let us talk about habits for long-term success with Pandas. ## best practices and performance tips. Always scan the top and bottom of your data with .head and .tail. Use df.info and df.describe to explore data health early. For large datasets, try to process columns instead of rows for faster performance. Prefer chaining methods for concise, readable code. Save checkpoints with _CSV so you can reload without starting over. Running the cell now. Remember, good habits save you time and make your code easier for others to read. Let us quickly review some errors you might see and how to fix them. ## troubleshooting, common Pandas errors. Key error, this means the column name you wrote does not exist. Value error, sometimes this occurs when shapes of data do not match up. Setting with copy warning, Pandas warns you when your changes might not update the original data. To fix, double-check your column names and use .copy as needed. Running the cell now. Do not let errors stop you. Everyone sees these sometimes. Let us see what happens if we make a typo in a column name. This comment explains there is an intentional error due to a misspelled column name. Start a try block to attempt code that may cause an error. Calculate the mean of the column tag, which is misspelled and will cause an error. Catch a key error exception that happens if the column name does not exist. Print the error message to help understand what went wrong. Running the cell now. Here, the key error occurs because the column name ag does not exist in the data frame, highlighting the importance of spelling column names correctly. This output teaches us to double-check column names to avoid such errors during data selection. Try correcting the typo and see that the code works fine. Let us search the dataset for passengers by name. We prompt you to type part of a name you want to search for. We ask the user to input a few letters to look for in passenger names. We filter the data frame to find all rows where the name column contains the input, ignoring case. We display the first 3 matching rows, showing selected columns to review the results. Running the cell now. This output shows the first 3 passengers whose names contain the input string, demonstrating successful filtering using street contains. Notice the consistent columns displayed, name, age, sex, and fare, helping you verify that the filter worked without any key error. This confirms the code correctly narrows down rows by partial name matches, a key skill in troubleshooting data selection. Change the letters and try to find different passengers. Let me know in the comments if you got a match. Let us summarize what you now know about Pandas. ## recap, what you learned. How to load data and check shape and columns. Cleaning, selecting, filtering, and grouping data. Making pivot tables and simple charts. Handling common errors in Pandas. Practice problems for more confidence. Running the cell now. Practice these steps with different datasets to build your data science skills. Thank you for spending time learning Pandas with us. ## thank you for joining. If you enjoyed learning Pandas with us, please hit like and subscribe. We would love to hear your questions or suggestions for future lessons. Try exploring a new dataset using what you have learned today. See you in the next lesson. Running the cell now. Remember to subscribe if you want to see future Pandas tips and tutorials.